Okay, welcome back to this segment of our lesson. In the last lesson, we looked at the cosine ratio, okay, and how to use the angle given together with the cosine ratio, okay. So in today's or this segment of the lesson, we're going to look at the tangent ratio, okay. The tangent ratio, okay. Now we've already looked at the three ratios in our introductory part of the lesson. Let's go back and see what two sides are used in the tangent ratio. All right. The tangent ratio, okay, let's say tan theta is equal to, this time, opposite over the adjacent. Now, what do we notice about this ratio? We're not using the hypotenuse, okay? So let's look at a triangle given angle theta, okay, opposite and adjacent, okay. So hypotenuse here is not relevant when we are using the tangent ratio. Keep that in mind, okay. Let's review. We've already looked at all three ratios. How can we remember what ratio to use? How do we remember all these formulas? It's too much, okay? Now, there is an easy way of remembering. We use what is called an acronym. What's an acronym? You learned this in English. We use the first letter of each word to form a new word that is easy to remember, okay? So, let's see what the ratios are. We have sine theta, which is equal to opposite over hypotenuse, all right? Then we have cos theta, which is adjacent over hypotenuse, and tan theta, which is opposite over adjacent, okay? Sine theta, opposite over hypotenuse, cos theta, adjacent over hypotenuse, and tan theta, opposite over adjacent, okay? Opposite over adjacent. How do we remember all of these? We use the acronym SO, CA, TOA. All right? SOHCAHTOA. Now, what does SOHCAHTOA mean? We have only used the first letter of each of these words here to form this one. And that should help us remember. SOHCAHTOA. S stands for sine, O stands for opposite, H hypotenuse, all right? Cosine, all right? Adjacent, hypotenuse, and then we have tangent, opposite, and adjacent, okay? If you find this is too much, you can also use some old hens can't always hide their old age. Let's write that down, okay? Let's see. Some old hens can't always hide their old age, okay? So you can see sine, opposite, hypotenuse, cosine, adjacent, hypotenuse, and the last ratio, tangent, equal to opposite over adjacent, all right? So SOCATOA is the first acronym you can use, and you can also use this one, which says some old hams can't always hide their old age. Okay. Now, let's go back to the tangent ratio, which is what we are covering today. We are going to use a triangle and see how we apply the tangent ratio. Okay, so let's look at the first example. We have a triangle with an angle of 35 degrees. Okay, this side here is x, it is unknown. All right, and this side here, which is the adjacent, is 7 meters long. Okay, so x is the opposite, and here 7 meters is the adjacent. Okay, now hypotenuse is not given. Like I said before, when we use the tangent ratio, the hypotenuse is not used. It is not relevant, okay? Because we only need opposite side and adjacent side, okay? So let's use the ratio. Tan of the angle given, which is 35 degrees, equal to opposite, which is x, over the adjacent, which is 7. Okay? The working out is very similar. It's the same as in the last two ratios. So we only move this one. The only difference here is the tangent ratio now. So when we use 10, it will be a different value here. Okay? So let's take 7 across. We have 7, 10, 35 degrees is equal to x. Okay, 7 times, and remember you are using the 10A textbooks, which have the tables in the back. All right, so the value of 1035 degrees is 0.7002. Okay, now we are going to multiply. Again, be very careful when you're multiplying decimals. 0.7002 multiplied by 7. Okay, 7 times 2 is 14. 7 times 0 is 0, plus 1 is 1. 7 times 0 is 0. 7 times 7 is 49. Okay, now we move our decimal point 4 times to your right. Okay, so the length of x, or the opposite side in this example, is 4.9014. Go back to your triangle, meters. Okay, equal to x. All right. Now let me stress here again, if you are asked to round this off, then you round off your answer. Otherwise, it stays as 4.9014 meters. Okay? Now, we've looked at all three ratios already. We have sine, okay, cosine, and the tangent ratio. Now, how do we know when we are going to use either of these ratios? Let's look at a word problem that might help us, okay? Now, let's say, for instance, that some surveyors have come to survey a piece of land, but in that piece of land, there is a river that runs through that piece of land, okay? So let's draw this river. We'll draw a diagram so this helps us understand where the triangle is located. Okay, so we have a river. Okay, let's just draw in this so we don't Okay, so we have a river, and on one side of the river, there are two survey pegs located 80 meters apart. Okay, two survey pegs that are located 80 meters apart on one side of the river. On the opposite bank, there is a navigation beacon placed opposite one of the survey pegs. Okay, let's just draw a circle to represent this navigation beacon. Okay, so it is directly opposite one of the survey pegs. Now, if it's directly opposite, then we know that it forms a right angle. Okay, so your navigation beacon directly opposite one of the survey pegs, which forms a 90-degree angle here. Okay, now from here to here, they found that the angle formed between that navigation beacon and the second survey peg is 32 degrees. Okay, 32 degrees. We need to find the width of the river, this group of surveyors, because this river forms part of the land that is being surveyed. All right, so if we are going to find the width of the river, it is unknown. We are going to represent that with x. Okay, now once we have our diagram up, we can put in the name of the sides so they help us to identify which of the ratios to use. Okay, now remember, the side that is opposite the angle is opposite. Okay, and the side which is next to the angle is the adjacent. Okay, so we have opposite and adjacent given, no hypotenuse given, so that means we are going to use the tangent ratio. The tangent ratio does not require the length of the hypotenuse. Okay, so let's use tangent ratio to find the width of our river. Okay, so theta here is 32 degrees, 10, 32 degrees equal to opposite is x, and our adjacent is 80 meters. Okay, now take 80 across, so we have 80, 10, 32 degrees equal to x. All right, so let's take our tables out again and check to see the value of 10, 32 degrees. Okay, so according to our tables, 10, 32 degrees is 0.6249. Okay, 0.826249. Okay, so 80 times 0.6249 equal to x. All right, so we are multiplying here. All right, so let's have a look at 80 times 0.6249 equal to x. Okay, now again, be careful with your decimals. Let's see, we'll multiply up here. 0.6249 multiplied by 80. Put down our 0. 8 times 9 is 72. Okay. 8 times 4 is 32. Plus 7 is 39. Okay. 8 to 16 plus 3 is 19. All right. and 8 times 6 is 48 plus 1 is 49. Okay, again 4 decimal places. So let's move 1, 2, 3, 4. All right, 49.9920. Okay, let's put that down. X is equal to 49.992 from our measurements here in meters. All right, okay. So what does this mean? The width of the river is 49.992 meters wide. Okay. Now, in our next lesson, we are going to look at the tangent of complementary angles, and we are also going to look at how to find the angle when two sides are given. Of course, we are using these ratios here to help us find the angle. Until then, I'll see you in our next lesson.